Alright, so far we have created three portfolios with different sets of weights. These are portfolio 1. That's the one with the minimized risk for the entire world within the 4 stocks. And the portfolio 5 is the one with the highest possible return. And market portfolio is the one with the highest Sharpe ratio. For your information, Sharpe ratio is return minus risk-free rate divided by the risk. So the high Sharpe ratio indicates either the return is high at the numerator or the risk is low at the denominator, or both. Okay, and since our topic here is efficient frontier, so let's learn how to construct efficient frontier. Well, you see that we still need to create 3 portfolios. These are portfolio 1, 2, 3. So the current setup is still equal distributed weights, but I'm going to change that momentarily. So the difference between 2, 3, and 4 with the others are the expected return. So right here, you see for portfolio 1, the expected return is itself. Okay, that's the target return. So I'm going to construct 3 returns. So you will see that from 8.84 all the way to 11.02, the return keeps increasing 4 times. From 1 to 2, 2 to 3, 3 to 4, 4 to 5. The return increased by 4 times. So I'm using the difference, which is the highest return in the portfolio world for the 4 stocks, minus the lowest divided by 4. So that's the increment each time from portfolio 1 to 2, or from 2 to 3, or from 3 to 4, plus the previous return. And the increment should be the same. Okay, so I lock these 2 cells, hit enter, use format painter to reduce the pound keys because make it look nicer, and then drag it all the way. So as you can see, from 8.8 to 9.4 to 10 to 10.5 to 11, these 5 portfolios have the return increasing in the same amount. All right, and then I will need to replicate the results here, and but for now I will calculate the returns for each portfolio. Okay, this is for portfolio 2, so I select the weights in portfolio 2. Okay, Control Shift Enter. Don't just hit enter by itself. And then I have the stocks returns in the first month times the weights for portfolio 3. Lock them. Control Shift Enter. And then sum of the same stock return in the same month times different weights, even though it's the same number. That's for portfolio 4. Be very careful. Even though it's the same number, but that's in different row. All right. Okay. Control Shift Enter. And then I'm going to drag it all the way down. Okay. And edit the format. And then I will need to drag all these results to calculate their expected return, standard deviation, and Sharpe ratio. All right, so now my work focus on portfolio 2, 3, 4. I want the return generated from the weights to be equalized to this target return. You can see each portfolio are different in terms of target return, but each portfolio should have their risk level reduced to minimum. Okay, so let me first work on portfolio 2, and then I will repeat the same process for 3 and 4. So this time I need to minimize portfolio 2's risk by changing portfolio 2's weights. Okay, and then the previous constraint, I need to delete them, add the first weights as the portfolio total weight equals to 1 or 100%. I'm fully invested. The second weight, that's the key part of it, is the portfolio 2's return is the target return. Okay, it's target return. Okay, solve. Then this part is done. So portfolio 2 is done. And then perform solver again. This time I need to do portfolio 3's risk. Okay, by changing portfolio 3's weights. Okay, and I wanna delete the previous constraint, delete them, and then add new constraint, which is portfolio 3's weight equals to 1. Okay, and then portfolio 3's return equals to the target return for 3. Okay, add. Oh. Okay, so these are all done. Click on solve. So let me just do it one more time, or the last time, for portfolio 4. So my goal here, zoom in a little bit, zoom out a little bit. My goal here is to minimize portfolio 4's risk by changing this portfolio's weights. Okay, delete, and add portfolio 4's weights equal to 1, and add another one, which is portfolio 4's return equals to the target 10.48. Click on OK, then solve. Okay, this part is done as well. So now I have 5 portfolios, and they are ripe to construct the efficient frontier. As you can see, all the all the risks here from 1 to all the way to 5, all the risks are minimized using solver, and they came up with a different level of returns. Okay, they came up with a different level of returns. Let me just put a borderline here. Under each return, you have a portfolio, the optimized portfolio, giving the lowest level of risk. Okay, but if you look at the portfolio for the market portfolio, it's following a different story, because you see here that the market portfolio has the highest Sharpe ratio, which combines both standard deviation and expected return, instead of considering the risk only. Okay, so how do I construct the efficient frontier? So that's gonna be pretty straightforward. You can use the expected return and the standard deviation. So you are going to click your a random cell, a blank cell, and then insert. I want you to select this chart, and it's a chart with marker, first row, second column. Okay. All right. And then I will right click, select data, add a series, and the name of it, efficient frontier. Okay, the X values will be the risk from portfolio 1 to portfolio 5. Okay, 1 to 5. And the Y values will be the expected return from 1 to 5. So 5 cells in the same row. Okay, so this is the efficient frontier I have right now. Okay, and then I can edit it a little bit. So I want to make the vertical axis a little bit shorter. I want to make the minimum instead of 0. I want to make it 0.02. Okay, 0.06. All right. Okay. Now it's a little bit more shaped. Okay. And for the market portfolio, I want to make it as a different series. Okay, so add a different series, and the name of it, market portfolio. The X value would be the risk. Okay, the y value would be the return. Okay, you can see the market value is really following is on the efficient frontier as well, because that's also the best portfolio at a given return, and this return is 9.01%. It's not even listed here, but the market portfolio is another good choice for you. Okay, so this part is done, and the next is well, you can see we had a very hard time to calculate all the returns. Okay, to calculate all the returns for each portfolio for each month before we can calculate their expected return and the standard deviation. Okay, there's another way to do it. So instead of calculating the monthly return for the portfolio, you can just directly work on the standard deviation, okay, based on the individual stock return, based on individual stock standard deviation. Okay, so I'm talking about this standard deviation and the portfolio standard deviation. So how can I calculate that? This time, I will need to use the variance covariance matrix for the 4 stocks. Okay, so right here, I have this matrix as my illustration. So you will see that in order to calculate the portfolio, that's the portfolio standard deviation. If you take the square root out, that's going to be sigma squared, the entire thing under the square root. So basically, under the square root, that's the variance. And the variance is a W1 times sigma 1 both squared, and you get the same part for the second stock, and then you get the interaction part. And this whole thing can be used can be calculated based on variance covariance matrix. So let's say if W1 equals to 1. Okay, let's say W1 equals to 1, just as some random example, W2 equals to 2, and the variance, which is a sigma 1 squared right here, equals to 3, and sigma squared 2 equals to 4. Okay, and then sigma and the covariance of the two, which is row 1, 2, the correlation, and this individual standard deviation, that's called the covariance. Let's say they equal to 5. No, let's say they equals to 2 as well. Okay, that's a covariance. Okay, and then that's a weight 1, weight 2. So I can use the matrix multiplication. So I will just show you, I will use this matrix times this matrix, which is the variance for 1, the variance for 2, and covariance of 1, 2, and covariance of 2, 1, which is the same. And then you also have this matrix. Okay, you can multiply 3 matrices together to get the variance for the portfolio. Okay, so if we follow the standardized way, if you use just a 1 formula, so that's going to be the variance is going to be the weights for 1 squared times the sigma 1 squared, which is a 3, that's the variance, plus the weight 2 squared times sigma 2 squared, okay, plus 2 times 1's weight times 2's weight. I know they should add up to 1%, but to 100%, but let's say just give you random numbers for easy illustration. And the covariance should be 2. Okay, so the number is 27 if you follow the formula to do it. Okay, and if you use the variance covariance matrix, so you should use mult, and you're gonna use this column, this row times this matrix. Okay, so that's gonna give you a matrix, a 1 by 2 matrix, 1 row and 2 columns. Okay, and then you're gonna do another round of amount. So that row, okay, the results here will give you the row will be multiplied by the column here. Okay, since this involves matrix or vectors of cells, you know how to finish it. It's going to be Control-Shift-Down arrow. So that's going to give me the same result. Okay, this will give me the same result. Why do I bother to create the column here, the row and column and the matrix here? Because in reality, you would have faced a more complicated situation than this one. Right here, you only have 3 stocks. In reality, you will have n stocks. N could be 30, could be 40, could be 50. And if that's the case, it's very hard for you to follow the same formula, because you're gonna have 5 sigmas, and you're gonna have let's say how many covariance. If you have 50 stocks, then you will have let's say 1200. Okay, at least 1200 covariance. So you will have 1200 covariance paired together and 50 sigmas items like this. So that's going to be too complicated for you to calculate. Okay, like this formula is showing you. Okay, all the weights. The best way to do it, instead of using this formula with 1200 covariance or pairs, you do this kind of calculation. You use the weight row times variance covariance matrix, then multiplied by the weight column. Alright, and this one in the middle is called a variance covariance matrix. You see covariance between stock 1 and itself is a variance for 1, and the covariance between stock 2 and itself is a variance for 2, so on and so forth. And covariance between 2 and 1, the covariance between 1 and 2, they are the same, so they have the same numbers if they are cross diagonal. Okay, so that's the basic underlying theory to calculate the portfolio standard deviation or variance when you have so many stocks. Okay, and if you want to know how to perform the variance calculation, the matrix calculation, here's an example. So let's say I have a row here, and I have a column here. This is my matrix 1. And this is my matrix 2. Okay, so if I use a 1 times matrix 2, then I will have one single number as the answer, because if I multiply these two together, use x for multiply, then I will have 1 times 3 plus 2 times 4. Okay, so that's going to be 11. Or I can use matrix multiplication. M stands, the first M stands for matrix. Then this row times this column. Control-Shift-Enter to finish. I got 11. Okay, so that's how you get a single answer. But the thing is, if you use matrix 2 times matrix 1, that's going to be different. Okay, let's say if I have a matrix 2 here. Okay, oops. Should be copy, and then times matrix 1. Okay, and if I do that, yes, if I just use one single cell to perform it, it will give me one output as a result. Control-Shift-Down is 3, but actually it's not 3. It should be a 2 by 2 matrix. So I'm talking about this part. So if I do such matrix calculation, if I start with a column instead of a row, then the calculation would be 3 times 1 as the first number here, and then 3 times 2 is right here, 4 times 1, and 4 times 2. Okay, so that's how I will do it. So that's how it's gonna do the calculation. Okay, so it's a 3 times 1. Let me do it. 3 times 1, and then 3 times 2, and then 4 times 1. Sorry, 3 times 2 should be here, and then 4 times 1, and then 4 times 2. Okay, so the result will be like this. Okay, so even though the result is showing here, but that even though there's only one result, one number here, but that means I did not do the right thing. So I will cut this formula, and I need to select the entire area and then put the formula here. Okay, because the output will be a 2 by 2 matrix, so I need to select the whole area in the gray, and then Control Shift Enter. So this is how I got the result. So the bottom line is, please remember, if you messed up the order of the column and rows, your number will be different. Okay, your number will be different. And the format, the matrix will be different. If you use 1 row times 1 column, you're going to end up with a single answer, single number. If you use 1 column times a 1 row, then you're going to end up with a whole matrix, multiple rows and a multiple matrix. So if you don't believe me, then I can tell you, if I do this, if I select a 2 by 2 matrix, and I still do the first calculation, matrix 1 times matrix 2, and mult. Okay. And even though I have four places to show the numbers, but they're going to show me the same numbers. Okay, so which means I don't need to select the 4 cells. I just need to select 1 cell. That's good enough, which is this cell. Okay, just 1 cell is good enough. Okay, because the number will be just one. The output will be just one single number if I use a row, start with a row, multiply by a column. Okay, if I use column first, multiply by a row, that's going to be a very different situation. Okay, so back to my calculation here. So if I have, let me delete all this. So if I have 3 stocks, so I will use W1, 2, 3. Okay, and then my variance covariance matrix will have variance 3 here, and then the covariance between 3 and 1, variance covariance between 3 and 2 here, and the covariance between 2 and 3, and the covariance between 1 and 3. Okay. So that's how much I'm going to extend. Then for this row, for this column, I need to extend from 3 assets to from 2 assets to 3 assets. Okay, and you can see that if I keep expanding the number of stocks in my portfolio, I will have more weights: W1, W2, W3, all the way to W4, W5, W10, W100. And it's going to be extended all the way down. And then my variance covariance matrix will expand again, on and on, just like what this picture is showing us. Okay, so how exactly do I apply this into my portfolio calculation? Okay, let me just put it here. Variance covariance matrix. So number 1, you should know how to calculate the variance and the covariance based on the stock returns.